Question 3, Part A. I have an expression for V here. V is t cubed over 4 minus 3t plus 5. And I'm asked to find dv by dt. So remember your rules of differentiation, round and down. Take the power of t round to the front and reduce the power by 1. Reduce the power in the next term and I'm left with 3. And differentiating the constant term 5 gives me 0. So that's it. Part B, Part 1. Find the rate of change of volume when t is 1. Well, the rate of change of volume is dv by dt. So the question means find dv by dt when t is equal to 1. So let's substitute t equals 1 into my expression above. And get my answer, which is minus 2 1/4. And the units are meter cubes per second. You still get the mark even if you don't put the units in. Question 3b, Part 2. Hence determine with a reason whether the volume is increasing or decreasing. In order to do this, we need to see what the gradient of the function is. So when t is equal to 1, let's find dv by dt. Well, we've already done that in B Part 1. So I know that dv by dt is minus 2 1/4. Now because this gradient is negative, this means that the volume is decreasing. Explain your reason carefully in order to get the mark for this question. Question 3c, Part 1. We need to find the positive value of t for which v has a stationary value. A stationary value or stationary point, abbreviated here by SP, occurs when dv by dt is equal to 0. So let's put the expression for dv by dt, which we obtained earlier in Part A, equal to 0, and find the value of t. So this has two solutions. T is equal to 2 or minus 2. But we just want the positive solution, so our solution we want is t is equal to 2. We don't want the negative solution because time can't be negative. Question 3, Part C, Part 2. We need to find d2v by dt squared. So we need to take our expression for dv by dt and differentiate it again. So use the same rule for differentiating, round and down, so reduce my power of t by 1 and bring the power down to the front, and that's what we get. So d2v by dt squared is 3t over 2. Now at this stationary point t is equal to 2. Found that in C part 1. So d2v by dt squared here is equal to 3, and this is a positive value. And if d2v by dt squared is positive, that means the stationary point must be a minimum.